Let's dive right into this explainer. Today, we're exploring why deploying AI in high-stakes environments isn't actually just a tech problem. It's fundamentally a governance and authority design problem. Look, we see wild headlines about AI capabilities literally every single day. But the real question keeping leaders up at night is this: how do you actually maintain control when algorithms start making critical financial and operational decisions? Imagine a trading algorithm dumping millions in assets in a fraction of a second, or a massive autonomous robotic supply chain system just freezing up during peak season because it hit a scenario it wasn't trained for. When things are moving that incredibly fast and at that scale, who is actually in charge? Well, that's exactly what we're tackling today.
Here's our roadmap. We'll cover the AI governance challenge, the limits of algorithms, engineering algorithmic stability, the human-AI partnership framework, and wrap up with designing decision authority.
Section 1, the AI governance challenge. There's this fantastic quote from Susanna Sierra in Forbes that really hits the nail on the head. She says, "Technology has ceased to be merely an operational opportunity and has become a central factor in board strategy and oversight." Essentially, AI can't just be handed off to the IT department as some routine software rollout anymore. We are way beyond that. Board members and executives have to develop the technical fluency to genuinely understand these systems. You have to integrate them into core strategy and anticipate both the massive risks and the unprecedented opportunities. If you're sitting in the boardroom today, technology is your domain, whether you have an engineering background or not. When we look ahead to the 2026 proxy season, investors are heavily scrutinizing how boards are managing 5 specific trends to navigate uncertainty. Take boards that anticipate risks, for example. We can't just react to operational failures anymore. We're expected to predict them. Or think about geopolitics and supply chain resilience. How exactly does a pure optimization algorithm account for a sudden geopolitical embargo or a massive port strike? Spoiler alert, it can't, not on its own. We're also looking at combining a diversity of perspectives, using technology as a strategic driver, and building a culture of adaptability to pivot when disruptions hit. To safely deploy AI amidst all this complexity, organizations absolutely need frameworks that let the AI do the heavy analytical lifting while keeping human oversight firmly at the steering wheel.
Section 2, the limits of algorithms. The crucial thing to understand here is that both extremes of decision-making fail spectacularly in modern high-stakes environments. Relying only on humans to analyze massive datasets is basically like trying to empty the ocean with a teacup. Behavioral research proves that human judgment completely struggles with scale. We get fatigued, we have cognitive biases, and we're famously inconsistent. But an unbounded AI-only approach? That's just as terrifying. It's like putting a brick on the gas pedal of a sports car while wearing a blindfold. Sure, it's efficient and crazy fast right up until you hit a wall. It wasn't trained to see. AI leans so heavily on historical data that it vastly underestimates rare, high-impact safety risks. It optimizes blindly for short-term efficiency. And honestly, the worst part, it diffuses accountability. If an autonomous system makes a catastrophic capital allocation, who's responsible? You literally can't put an algorithm on trial.
Section 3, engineering algorithmic stability.
So what does unbounded AI actually look like when it's running? If we look at standard Bayesian optimization, which is basically an AI desperately chasing maximum financial returns without any real concept of risk management, it's a mess. Notice those wild, erratic spikes and deep drops? That's the AI bouncing around blindly, exploring potentially disastrous regions just because it's single-mindedly chasing pure performance. The objective scores are scattered everywhere. In real-world financial markets or large capital projects, that kind of instability is a total non-starter. You simply cannot have systems swinging wildly just to squeeze out a slightly better margin. It wastes resources and introduces massive systemic risk. But here is where the math gets genuinely exciting. When we introduce a mathematical guardrail, like a TPES model or what data scientists call an adaptive weighted Lagrangian estimator, we're basically putting a strict speed governor on that AI engine. Look at how the performance scores are now tightly, cleanly clustered right at the top. We've penalized the AI for being unpredictable. We are explicitly telling the algorithm, yes, go ahead and maximize expected returns, but you must minimize the variance of those returns. By engineering stability straight into the objective function, we force the AI away from erratic behavior and into highly stable, profitable zones. We trade a tiny fraction of theoretical maximum performance for a massive, real-world gain in reliability. Section 4, the Human-AI Partnership Framework.
Okay, so how do we take that tight mathematical control and apply it to the messy physical world? Like, say, deploying millions of dollars in industrial robotics. You need a highly actionable operational model. When you deploy large-scale physical assets, you're making irreversible capital commitments. The costs of facility integration and decade-long maintenance almost always dwarf the initial hardware purchase. You can't just plug these systems in, cross your fingers, and hope for the best. You need a structured allocation process where human governance is the steering wheel and AI is the engine. Think of this as a continuous, looping conversation between human expertise and machine intelligence. It breaks down pretty cleanly. First, humans set the absolute non-negotiables, the strategic intent. Then, AI does the heavy analytical lifting, constructing scenarios based exactly on those constraints. Next, humans step back in to give the final binding approval. Once it's deployed, both human and machine monitor the system together. And finally, if things drift off track, humans retain the absolute authority to escalate and reallocate resources. It's an ongoing loop of learning and strict authority.
Let's make this super concrete by looking at explicit authority boundaries. In that first stage, strategic intent, notice that AI has literally zero role. Humans define the objectives. If you let an algorithm define your core business goals, you're asking for trouble. Now, down in scenario construction, the AI models costs and risks at a speed we just can't match, while humans validate the underlying assumptions. For capital approval, the AI explains its outputs, but the final sign-off is 100% human. And in deployment monitoring, the AI is your ultimate watchdog, instantly flagging real-time deviations. But, and this is key, humans have to interpret those signals to prevent alert fatigue. The lines of responsibility are crystal clear. The AI provides bounded analytical support, but it never dilutes human accountability.
Section 5. Designing Decision Authority.
This brings us to a really clear definition of what good governance actually means today. AI governance is the explicit engineering of decision authority boundaries, escalation points, and accountability mechanisms between human judgment and algorithmic support. Good governance isn't a cage for AI. It's the deliberate design of decision boundaries so your organization can master scale, uncertainty, and accountability all at the same time. Because let's face it, analytical consistency from an algorithm won't save your company from a multi-million-dollar mistake. As leaders, you have to actively draw the line where the code stops and human responsibility begins. As this technology continues to evolve at breakneck speed, the organizations that really thrive won't necessarily be the ones with the smartest algorithms. They're going to be the ones with the smartest architecture of responsibility. So, I want to leave you with a provocative question to chew on for your next board meeting. Are you just deploying algorithms, or are you designing accountability? Thanks for joining me for this explainer. Catch you next time.